Hi guys, I am Kritik Khanna and I am here to tell you about my project score based ranking of the documents. Now before this you need to know what is the information retrieval is. Information retrieval is obtaining the relevant information from a large set of data. This information is used basically in web search engines when you type the query on the public library, and it is used basically to reduce the information load. This is the model of the IR system in which user enters the query, then there is a database in which the query is matched with the database records, and the final result is given to the user in the form of documents or whatever. Now ranking this information, the results at which you get in the form of your documents and all, this basically includes the ranking of those documents. These ranks are top ranked documents are retrieved in the form of based on these simple ranking functions, in which some of them are the constant ranking functions. TF-IDF means there are various techniques of ranking a document, and in which I'll be implementing in my project is the score based ranking. So before this you need to learn what exactly I am implementing in my project. In my project I am working on basically the two techniques. One is the textilling and the other is the standard score calculation, which I have implemented on a large set of data. Now let me explain you about what exactly the textilling is. The textilling includes basically the three steps. Number one is the tokenization, second is the score calculation, and third is the boundary identification. In the first step, the text of the documents and the query will tokenize into various tokens which are in lowercase in order to form a token sequence of specific size. Each token size is separated by a gap I. A record is also kept of the locations of the paragraph breaks within the text. Next step is score is then calculated for each gap of I, which is done as the number of never yet seen words in the token sequence to the left of the gap is added to the number of never yet seen words in the token sequence to the right, and this number is divided by the total number of the tokens into the two sequences. Finally, the depth score is computed at the boundary identification, in which the program records the lexical score of the token sequence gap to the left of I until the score of I minus 1 is smaller than the score of 1. Similarly, for token sequences to the right, the program monitors the score of the token sequence R, which is the right one, until the score of R plus 1 is less than that of R. Finally, score of R minus score of I is added as the score of left minus score of I, and the result is the depth score. The formulas for this are as follows. This is this formula for the score calculation of score of I, in which the formula is score of I is equal to num new terms b1 plus num new terms b2 upon length of b1 plus length of b2, in which the num new terms are the number of new terms in the left sequence of gap I. Num new terms b2 is equals to the number of new terms in the right sequence of the gap I. Length of b1 is the number of terms in the left sequence of the gap I. and length of B2 is the number of terms in the right sequence of the gap I. Now formula for the depth score is calculated as depth score of I is equal to the score of right sequence minus score of current sequence gap plus the score of left sequence minus score of the right sequence. So now coming back to the